In this video, we shall see how to integrate using U-Substitution. Let's say we have the integral of 4x to the power of 2 times x to the power of 3 and then plus 7 raised to the power of 4 times dx. What should we set u to be equal to? If we set u to be equal to x to the power of 2, the derivative of x to the power of 2, which is 2x, cannot cancel with this x to the power of 2. So we cannot set u to be equal to x to the power of 2. Instead, we shall set u to be equal to this. So we shall have x to the power of 3 plus 7. And if we differentiate this, du will be equal to the derivative of x to the power of 3, which is 3x to the power of 2. And the derivative of 7 is 0 times dx. And this x to the power of 2 will be able to cancel with this. And to find dx, let's divide both sides by 3x to the power of 2. This will cancel with that. And so we shall have dx equaling to du divided by 3x to the power of 2. And now we shall replace this with u and then replace dx with this. So this will be equal to the integral of 4x to the power of 2 and then times x to the power of 3 plus 7, which is u, raised to the power of 4 times dx, which is du, divided by 3x to the power of 2. This will cancel with that. And so we shall have the integral of 4 divided by 3 times u to the power of 4 du. And now we can take out 4 divided by 3. So this will be 4 divided by 3 times the integral of u to the power of 4 du. And this will be equal to 4 divided by 3 times, if we integrate this, we shall raise the power of the exponent by 1 and then divide by the new power. So we shall have u to the power of 4 plus 1, which is 5, divided by 5 plus c. And this will be equal to 4 divided by 3 times 5, which is 15, times u to the power of 5 plus c. And we know that u equals to this. So our final answer will be 4 divided by 15 times x to the power of 3 plus 7 raised to the power of 5 plus c. Now what if you had the integral of x times the square root of 6x plus 2 times dx? How can you integrate this using U-Substitution? Now whenever you have such a problem, all you have to do is set u to be equal to the complex part. So we shall set u to be equal to 6x plus 2. And if we differentiate this, du will be equal to the derivative of 6x plus 2, which is 6, times dx. And dividing through by 6, we shall have dx equaling to du divided by 6. And now we shall replace dx with du divided by 6, and then replace 6x plus 2 with u. So this will be equal to the integral of x times the square root of u and then times dx, which is du, divided by 6. Now from this, 6x will be equal to u minus 2, and therefore x will be equal to u minus 2 divided by 6. So this will be equal to the integral of x, which is u minus 2 divided by 6, and then times the square root of u times du divided by 6. 6 times 6 will be 36. And if we pull it out, we shall have 1 divided by 36 times the integral. Now this can be written as the square root of u times u minus 2 times du. And so we shall have 1 divided by 36 times the integral. Now if we expand this, we shall have the square root of u times u and then minus 2 times the square root of u and then times du. And this can also be written as 1 divided by 36 times the integral of u to the power of 1 over 2 times u to the power of 1 minus 2 times u to the power of 1 over 2 and then times du. And this will be equal to 1 divided by 36 times the integral of u. Now whenever you are multiplying numbers of the same base, you add the exponents. So this will be 1 divided by 2 plus 1. minus 2 times u to the power of 1 over 2 du. Now 1 divided by 2 plus 1 is the same as 1 divided by 2 and then plus 2 divided by 2. And since we have the same denominators, we can combine the numerators. So this will be 1 plus 2 divided by 2, which is equal to 3 divided by 2. So this is equal to 3 divided by 2. So we shall have 1 divided by 36 times the integral of u to the power of 3 over 2 and then minus 2 times u to the power of 1 over 2 du. And now we can integrate. So we shall have 1 divided by 36 into, this will be u to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 and then minus 2 times u to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1 and then plus c. And we know that 1 divided by 2 plus 1 will give us 3 divided by 2. Now what about 3 divided by 2 plus 1? 3 divided by 2 plus 1 is the same as 3 divided by 2 plus 2 divided by 2. And this will be equal to 3 plus 2 divided by 2, which is 5 divided by 2. So we shall replace this and this with 5 divided by 2. So we shall have 1 divided by 36 into u to the power of 5 divided by 2 divided by 5 over 2 and then minus 2 times u to the power of 3 over 2 divided by 3 over 2 and then plus c. And at this point, let's multiply this by 2 divided by 5 and also multiply this by 2 divided by 5. And then multiply this by 2 divided by 3 and this by 2 divided by 3. This 3 will cancel with this and then this 2 will cancel with that. And for this 2 will cancel with this and this 5 will cancel with that. So we shall have 1 divided by 36 into, now this will be 2 divided by 5 times u to the power of 5 over 2 minus, now 2 times 2 divided by 3 will give us 4 divided by 3. So this will be 4 divided by 3 times u to the power of 3 over 2 and then plus c. And as you can see, 2 is the greatest common factor. So let's pull it out. This will give us 2 divided by 36 into, now for the first part we shall remain with 1 divided by 5 times u to the power of 5 over 2 and then minus, for the second part we shall remain with 2 divided by 3 times u to the power of 3 over 2 and then plus c. Now 36 divided by 2 will give us 18. And we also know that u equals to 6x plus 2. So this will be 1 divided by 18 into 1 divided by 5 times 6x plus 2 raised to the power of 5 over 2 minus 2 divided by 3 times 6x plus 2 raised to the power of 3 over 2 and then plus c. And that's our answer. Now what if you had the integral of x plus 1 divided by x to the power of 2 plus 2x plus 3 raised to the power of 4 times dx? How can you integrate this using U-substitution? Now for this example, what we need to do is set u to be equal to x to the power of 2 plus 2x plus 3. Because if we do this, we shall have du equaling to 2x plus 2 times dx, which is also the same as 2 into x plus 1 times dx. And this x plus 1 will be able to cancel with this. And if we make dx the subject, we shall have dx equaling to du divided by 2 into x plus 1. And now we shall replace dx with this, and then replace this with u. So we shall have the integral of x plus 1 divided by u to the power of 4 times dx, which is du, divided by 2 times x plus 1. This will cancel with that. And then we can take out 1 over 2. So we shall have 1 divided by 2 times the integral of 1 divided by u to the power of 4 du. So this will be equal to 1 divided by 2 times the integral. Now if we take this to the top, the exponent will become negative. So this will become u to the power of negative 4 du. And if we integrate, we shall have 1 divided by 2 into u to the power of negative 4 plus 1, which is negative 3, divided by negative 3 plus c. And this will be equal to negative 1 divided by 2 times 3, which is 6, times u to the power of negative 3 plus c. And if we take this to the bottom, the negative exponent will become positive. So we shall have negative 1 divided by 6 times u to the power of 3 plus c. And we know that u equals to this. So our final answer will be negative 1 divided by 6 times x to the power of 2 plus 2x plus 3 raised to the power of 3 plus c. Now we try out this. Solve the integral of x divided by 1 plus x to the power of 4 times dx. Now this can also be written as the integral of x divided by 1 plus x to the power of 2 raised to the power of 2 times dx. And at this point what we need to do is set u to be equal to x to the power of 2. Because if we do this, du will be equal to the derivative of x to the power of 2, which is 2x times dx. And this x will be able to cancel with this. And if we make dx the subject, we shall have dx equaling to du divided by 2x. And now we shall replace dx with this, and then replace x to the power of 2 with u. So this will become the integral of x divided by 1 plus x to the power of 2, which is u, raised to the power of 2, and then times du divided by 2x. This will cancel with that. And also we can take out 1 divided by 2. So we shall have 1 divided by 2 times the integral of 1 divided by 1 plus u to the power of 2 times du. Now whenever you have the integral in the form of 1 divided by 1 plus x to the power of 2 dx, this will always be equal to tan inverse of x. So if we integrate this, we shall have 1 divided by 2 times tan inverse of u plus c. And we know that u equals to x to the power of 2. So we shall have 1 divided by 2 times tan inverse of x to the power of 2 plus c. And that's our answer. Now let's say we had the integral of x to the power of 2 times the cosine of x to the power of 3 dx. How can we integrate this using U-substitution? In this case, we shall set u to be equal to x to the power of 3. And so du will be equal to 3x to the power of 2 times dx. And this x to the power of 2 will be able to cancel with this. Now if we divide through by 3x to the power of 2, this will cancel with that. And so dx will be equal to du divided by 3x to the power of 2. So this will be equal to the integral of x to the power of 2 times the cosine of x to the power of 3, which is u, and then times dx, which is du, divided by 3x to the power of 2. And so this will cancel with that. And we can also take out 1 divided by 3. So we shall have 1 divided by 3 times the integral of cosine u du. And this will be equal to 1 divided by 3. Now when you integrate cosine u, you get sine u plus c. And so our final answer will be 1 divided by 3 times the sine of u, which is x to the power of 3, plus c. Now you try out this. Solve the integral of tangent x dx using U-substitution. Now this can also be written as the integral tangent x is the same as sine x divided by cosine x, and then times dx. And what we need to do is set u to be equal to cosine x. If we do this, du will be equal to, when you differentiate cosine x, you get negative sine x times dx. And this sine x will be able to cancel with this. So if we divide through by negative sine x, this will cancel with that. And so we shall have dx equaling to negative du divided by sine x. So we shall replace cos x with u and then replace dx with this. So this will become the integral of sine x divided by u and then times negative du divided by sine x. This will cancel with that. And we can also take out negative 1. So we shall have negative integral of 1 divided by u times du. Now whenever you have the integral of 1 divided by x dx, this will be equal to natural log of x. And so the integral of 1 divided by u will be equal to natural log of u. So this will be negative natural log of u plus c. And if we put in the value of u, we shall have negative natural log of cosine x plus c. And if you want, you can further simplify this. From the rules of logarithms, we can take negative 1 to the top. And so we shall have natural log of cosine x raised to the power of negative 1 plus c. And if we take this to the bottom, the negative exponent will become positive. So this will be equal to natural log of 1 divided by the cosine of x to the power of 1, which is the same as cosine x, and then plus c. Now let's say we had the integral of e to the power of 5x dx. How can we integrate this using U-substitution? All you have to do is set u to be equal to 5x, and if you differentiate this, du will be equal to 5 times dx, and so dx will be equal to du divided by 5. And so we shall replace 5x with u and then replace dx with this. So we shall have the integral of e to the power of u times du divided by 5. And if we take out 1 divided by 5, we shall have 1 divided by 5 times the integral of e to the power of u du. And this will be equal to 1 divided by 5 times, if you integrate e to the power of u, you get e to the power of u plus c. And so we shall have 1 divided by 5 times e to the power of u, which is 5x plus c. Okay, try this. Solve the integral of 3x to the power of 2 times e to the power of x cubed dx. Now, for this example, what we need to do is set u to be equal to x to the power of 3. Because if we do this, du will be equal to, if you differentiate x to the power of 3, you get 3x to the power of 2 times dx. And this 3x to the power of 2 will cancel with that. So this will be equal to the integral of 3x to the power of 2 times e to the power of u, and then times, now dx will be equal to du divided by 3x to the power of 2. So this will be du divided by 3x to the power of 2. This will cancel with that. And so we shall have the integral of e to the power of u du, which is equal to e to the power of u plus c. And so our final answer will be e to the power of x cubed plus c. Let's look at our last example. Let's solve the integral of e to the power of y plus e to the power of y dy. Now this can also be written as the integral of e to the power of y times e to the power of e to the power of y times dy. And at this point we can set u to be equal to e to the power of y. If we differentiate this, du will be equal to the derivative of e to the power of y will be e to the power of y times dy. And so dy will be equal to du divided by e to the power of y, which is also the same as du divided by, now we set u to be equal to e to the power of y. So this will be divided by u. So this integral will become the integral of e to the power of y, which is u, and then times exponential e to the power of y, which is u, times dy, which is du divided by u. This will cancel with that. And so we shall have the integral of e to the power of u du. which is equal to e to the power of u plus c. And so our final answer will be e to the power of u, which is e to the power of y plus c. Therefore, that's how you solve integrals using U-Substitution. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.